Chapter 5, Rational Exponents and Radical Functions. We have 5.0 properties of exponents here. This is not in your Algebra 2 book. This is taken from an Algebra 1 book. It is just review to prepare to get us into what we're doing in Algebra 2. So, properties. Our first property we're going to talk about is the zero exponent property, and that basically means any number to the 0 power is 1. Any number except for 0, that is. 0 to the 0 power would be undefined. Any number, 5 to the 0 power is 1, 22 to the 0 power is 1, 675 to the 0 power is 1, negative 4.7 to the 0 power is 1. Okay. Negative exponents rule basically means that a to the nth power is a reciprocal of a to the nth power. A to the negative nth power is a reciprocal of a to the nth power. So if I have 4 to the negative 2 power, it is equal to 1 over 4 squared. So let's talk about this for a second. Okay, so if I have 5 to the 0 power, that's just 5. If I have 5 squared, that's 5 times 5, which is 25. I have 5 cubed, that's 5 times 5 times 5, 125, right? So what's happening is we're using exponents to make really large numbers, right? So that's really kind of the purpose. So let's think about it the opposite way, right? If I take this 5 cubed, how do I get to 5 squared? Well, 125 divided by 5 is 25. And if I go down from 5 squared to 5 to the first power, 25 divided by 5 is 5. So, if I continue that process, 5 to the 0 power is 5 divided by 5, which is 1. Right? So that's why anything to the 0 power is 1. And then if I go to negative exponents, I have 1 divided by 5, which is now 1/5. And 5 to the negative 2 power is 1/5 divided by 5, or something maybe like this. Right? 1/5 times 1/5 is 1/25. Alright, and if I go 5 to the negative third power, I have 1/25 divided by 5, and that's 1 over 125. So that's really the process. Anytime we talk about these negative exponents, we're really talking about very small numbers. Alright, so if I'm going to explain to you the size of an atom, right, extremely small, you can't even see, then I'm going to use a negative exponent to really represent that, most likely. Okay? Alright, so here we go. Number 1, evaluate each expression. 6 to the 0 power is what? Okay. 2 to the negative 4th power. Well, basically, I have the reciprocal, so it's really 1 over 2 to the 4th power. And what's 2 to the 4th power? Well, it's 16, so maybe I just simplify that to 1 over 16. Alright? And then here, I have, for C, I have negative 5 to the 0 power over 2 to the negative 2 power. Alright, so first of all, I have really negative 1, right? The opposite of 5 to the 0 power, which is 1. And then over 2 to the negative 2 power, well, when I look at that, what's really happening is I'm going to take it, I'm going to make it over 1, and I'm going to times it by 2 squared over 1. I'm going to take the reciprocal, right, of 1 over 2 to the negative 2 power, take out that negative, make the reciprocal, and now I have 4 times negative 1, and that's negative 4, and there we go. Alright, so if you could take a second, pause this video, and do number 2, A, B, and C, and I am going to go ahead and show the answers here. So please pause and work that out. Here are the answers. Okay, so let's go up here. A, negative 9 to the 0 power is 1. B, negative 3 to the negative 3rd power is 1 over negative 27. And C is 1 over 5x to the 5th power. Alright, very good. Next, I'm going to continue here. Our next property is the product of powers property. Alright, and basically it says to multiply powers with the same base, you add their exponents. For example, you can see that very well, is 4 to the 6th power times 4 to the 3rd power is equal to 4 to the quantity of 6 plus 3 power, which is 4 to the 9th power. Right, if you have like bases, you add the and you're multiplying, you add the exponents. Quotient of powers property. To divide powers with the same base, you subtract their exponents. 4 to the 6th power divided by 4 to the 3rd power equals 4 to the quantity of 6 minus 3 power, which is 4 to the 3rd power. Dividing, you have like bases, you subtract the exponents. Power of a power property. To find a power of a power, multiply the exponents. Yep, if we power, you multiply the exponents. So here, I have 4 to the 6th power, all that to the power of 3, which equals 4 to the quantity of 6 times 3 power, which equals 4 to the 18th power. Okay, here we go. A, I have 3 squared times 3 to the 6th power, that is equal to the 3 to the 2 plus 6 power, which equals 3 to the 8th power, and if you were to throw that in your calculator, you get 6,561. B, negative 4 squared divided by negative 4 to the 7th power. Like bases, what I'm going to do is subtract my exponent. So I have negative 4 to the 2 minus 7 power, which equals negative 4 to the negative 5th power, which equals, I'm just going to do it here, 1 over negative 4 to the 5th power, right? I take my negative exponent, basically put it in my denominator, reciprocal. And then if I were to go any farther, I could just do negative 4 to the 5th power is negative 1,024. And C, z to the 4th power, all that to power negative 3, is z to the negative 12th power. But we write using positive exponents to simplify. So what I would do is 1 over z to the 12th power. Okay, on the next page, number 4, there's a few problems for you to try. Go ahead and flip it up. Try those problems. Pause now because I'm going to go ahead and show the answers. Okay, there are the answers for, really should be number 4. Check those out and correct them if you got any wrong. Next, last 2 properties here. The first property is the power of a product property. Power of a product property. So it says to find the power of a product, find the power of each factor and then multiply. Okay, so see how it is in parentheses. So it's 3 times 2 to the 5th power. I could multiply 3 times 2 to get 6 to the 5th power. It will give me the same answer as if I distributed that power of 5 to both the 3 and a 2. So 3 times 2 to the 5th power is equal to 3 to the 5th power times 2 to the 5th power. And the power of a quotient property, to find the power of a quotient, find the power of the numerator and the power of the denominator and then divide. Okay, so we have 3 to divide by 2 to the 5th power. Again, I could divide first, but if you can't really, you distribute that power of 5 to both the numerator and denominator. So 3 divided by 2 to the 5th power is 3 to the 5th power divided by 2 to the 5th power. Alright, so let's do these up. So, the first one, A, it says simplify the expression. Write your answer using positive exponents, and I'm going to simplify a little farther than that. But here we go. So basically, I can't multiply those, right? So I'm really going to distribute that power of 2 to both terms. So I get negative 1.5 squared times y squared. And negative 1.5 squared is really 2.25 y squared if I were to simplify that. B, I have a divided by negative 10 cubed. So I can't really divide that, right? So I'm going to basically distribute, so I get a cubed divided by negative 10 cubed. And a cubed is just going to stay in that. By negative 10 cubed, I can make negative 1,000. Switch to colors maybe. Alright, C. I have 3b divided by 2 to the 4th power, which means I have 3 to the 4th power. D to the 4th power, all that are divided by 2 to the 4th power. And nothing really left to do but to simplify. 3 to the 4th power is 81. D to the 4th power, all divided by 2 to the 4th power, and that's 16. Okay, and the last one here, 2x over 3 to the negative 5th power. So again, I'm going to basically distribute that. There's a couple ways you could go about it, but 2 to the negative 5th power, x to the negative 5th power, 3 to the negative 5th power. And if I have a negative exponent, I'm really taking the reciprocal, so I'm going to flip this. So it becomes 3 to the 5th power over 2 to the 5th power, x to the 5th power. And then I could go one step farther. 3 to the 5th power is 243. 2 to the 5th power is 32. And x to the 5th power is just going to stay that. Okay. So, last problem here, number 6. Go ahead and try those 4. This is it. I will show these answers here in just a second. Pause now, and here are your answers. A, 1 over 1,000 y cubed. B, 1,024 over n to the 5th power. C, 1 over 16k to the 8th power. And D, 49 over 36c squared.